So thanks everybody to be here for this talk about change data capture. Like 17 years, I've been doing technical work. I've been a developer. I've been a team lead. I've been an architect. And I've always done that as a consultant. So I saw a lot of different environments, a lot of different projects, organizations, way to work. I was only doing Java projects. Recently, I taught myself Kotlin, which I love. And 2 years ago, I decided that, well, I've seen a lot of projects. I've seen that was the end. They were always nearly the same. So basically, you had customer, you had money, you had schedule, and you had to achieve something. And most of the challenges were not technical, they were organizational. And as a technical consultant, you cannot do anything. So I went to steer my career toward developer advocacy. So now I'm doing prototypes and fun stuff. I don't have any more schedules, and then I get to talk to many people in different parts of the world, which is a lot of fun. I work for a company called Hazelcast, so perhaps you might know about Hazelcast. We have two products. The first one is an in-memory data grid. So basically, we offer different data structures that are distributed. So if you're a Java developer, you will find, for example, the map. We call it IMAP to make a difference. Basically, the API is very similar. The only difference is that the data is distributed along all the nodes in the cluster. So you can do backups and you can do sharding and you can do a lot of stuff. The interesting bit about that is, well, it's more resilience than having it only on the single nodes. And it's much faster than putting that in the database. Our second product is called Hazelcast Jet. And since I will be talking about it later in the talk, I won't spend more time on that. So the agenda today is the following, probably caching. So why do we cache? What alternatives do we have to keep the cache in sync? Because you might know that there are a lot of different hard stuff in computer science, but mainly you will find that cache eviction is one of them. Then I will talk about change data capture because it's super high, but it's very, very powerful. I will describe very succinctly Debezium, and then I can show you how we use Debezium inside of Hazelcast Jet. And finally, I will try to show off with a demo that I hope will work. So caching. Why would you cache, actually? Because caching, you do it in general when you have low performance. But in fact, you don't always have very good performance. Like if you are using microservices, for example, and you rely on HTTP, that means that every time you will do a network call. And by doing a network call, you will incur the network cost. And sometimes you don't even know if the call was successful. You have no answer, so you're going to timeout. You improve the availability, you improve the performance, but there is a cost, and the cost is you don't always have the correct data. So for example, you can put a cache in front of your, let's say you are doing an e-commerce shop, you put a cache in front of your pricing microservice, and you accept that, well, you won't always have the right price. But it's a trade-off you are happy to accept because it's better to have a slightly wrong price than no price at all and you cannot sell. And well, you're an e-commerce shop. So here I have this like very dummy application. I have my app and I have a cache. And then we get the meanwhile, the application will be happy to read only about the cache. And so even if I don't only read, but I write, everybody is happy because the cache is the only way to update the application, and the app is the only way to update the application. So in that way, the cache and the database are always in sync. and everybody is super happy. But that's never the case. In a lot of cases, you will find something else, a component that will write in your database. And the problem is that your cache will become stale. As I mentioned, it might be pricing regarding microservices. In general, what will happen if you are using database is you will have some reference, and then when it gets updated, your cache is stale. So how do you keep both in sync? Because the database is a source of truth, the cache is only derived data. Well, you might know this quote: there are two hard things in computer science, naming things, cache invalidation, and off by one error. So that's the first thing to do is, hey, let's think about cache invalidation. About the semantics, there are two different, let's say, reasons to remove items from cache. The first is eviction, and eviction is when you reach the limit. Probably in the past, you had the need for the cache and you said, oh, no worries. Very good, because then you achieve something very fast. But then you notice that, well, the hash map will grow and grow and grow and grow. So most professional cache solutions, they have a hard limit. So you can configure the limit and you say, I can only have X items. The thing is, what happens when you want to add X plus 1? Well, since you can only have X items, you need to remove items from the cache. And so you have several strategies. You can have the least recently used, you can have the least frequently used, you can have other algorithm that you want to implement yourself. And this is cache eviction. So TTL is when you put an entry into the cache, you say, hey, this entry will have a TTL of 1 minute. After 1 minute, the cache will remove the entry. And so the entry won't be there anymore, and you will need to force reloading from your source of truth, the database, for example. So those are two distinct stuff. In that talk, I will only talk about the TTL because cache eviction is what happens under normal circumstances. So how do you choose the correct TTL? Well, if your batch says, hey, I will update the registry every day, well, it's very easy. Then you can have like but if you don't know the frequency, the update frequency, then there are basically two strategies. Either you will have updates, cache updates that are less frequent than the source of truth updates, and then you will miss updates. Or you will be more frequent, then you will be pretty sure not to miss updates, but then you will waste resources because you will try to ping the source of truth multiple times and nothing will have changed. So these frequent polling, frequent updates, it doesn't work. Actually, you need nowadays, you need to be event driven, because events mean if nothing happens, well, there is no need to update the cache. And if you have very fast, frequent updates, then as soon as you've got an update, you need to update the cache so you don't miss anything. So event-driven seems to be the right stuff for us. And if you are working with like a rational database management system, and I tell you event-driven, probably your first reflex is, hey, let's implement a trigger. Let's have a trigger. Well, the first issue is not all of databases, they implement triggers. And the second is triggers are very good if you stay within the database. If you need to call something that sits outside the database, well, it starts to be a bit painful. So for example, I checked how you can do it with MySQL. You can do triggers with MySQL, and actually you can call something that is outside the database. Of course, there are a couple of constraints, of limitations. So first, it must be written in C++. Then the operating system must support dynamic loading of libraries, which might not be very good if you're in an environment which is very security aware. Then it becomes part of the server. And I mean, you can read all about the documentation. It's a lot. But there is somebody who already did that. So he basically wrote a wrapper called like libmysql UDF sys. And basically what it does, it wraps any call that you do to a system call. So here, for example, you can create a trigger. And so every time you do an insert on my table, then you can call update row. That's amazing. And let's say that update row is an external process. Well, it seems to be working. To be honest, I didn't try it out, but from an architectural point of view, first it's implementation dependent. It's very fragile. Like at any point in the chain, there can be an issue, and you have no clue how to debug it. And who will be the maintainer of that stuff? Will it be a DBA? Will it be the developer? Will it be the famed DevOps who basically does everything that nobody wants to do? And I've heard from experience that triggers can be pretty much resource consuming if the update is too frequent. So that's not the best in breed, but it's already something, but we can probably do better. And then recently came something called the change data capture. And basically, change data capture is very simple. In a database world, it means that we are capturing every change, so insert, delete, update, that happens. And those changes, they are used and they can be sent as events. And in the wild, you can already have some ways to do that. You could have timestamps or version numbers or triggers, but basically the best and now the only way to do that is to scan the bin log. So what about this bin log? You might know this talk about Martin Kleppmann about turning the database inside out. And it tells about this like abstraction of a database. So if you are using a database, you don't really care about whether it's cluster or not. As a developer, you issue your SQL to an URL and it should work. But if you are an ops team, then you want to make sure that your data is persisted. And if you lose a node, then still the database will continue working. And for that, you have this leader-follower architecture in traditional RDBMS. Other more modern, they have no leader. They are all distributed. You can talk to any other nodes. But in traditional RDBMS, you have one leader. And in order for the follower to replicate data inside, then it writes its orders, its commands into a bin log. So it's an append-only log file. And the followers, they will read, and they will also take that and implement those SQL inside of their own like internal implementation, so that the follower is always sync with the leader. Of course, it's eventual consistency. It might take some time, but it's the case. And you might see it as an implementation detail, but actually we can use it. And so this bin log contains all those events. So if we could like listen, if we could read and interpret those files, then that would be super great. So there are two reasons for this log. Actually, there is replication is the second one. The first one is data recovery. What happens if you have a bug in the database? Well, that's not very important. As soon as the SQL is written into this bin log, then you can restart the process and the leader can reread its own bin log and restart from there. So let's hack the log. And here I've written a simple MySQL bin log extract, and you can understand already some stuff like update, where. Of course, there is a lot of stuff that is not very readable, and we would need to do that for every database that we want to have CDC on. So it would be like a Rosetta Stone, because you need to understand. And then we get back to our first problem. It's implementation dependent, it's fragile, and who will be maintaining it? I don't want to be the one maintaining it, but actually there are already an effort to do that, and it's called Debezium. And actually Debezium is a Java-based abstraction layer to read those bin logs. It's provided by Red Hat under an open source license. On the not super great side, it's very skewed toward Kafka. So if you want to use Debezium, I will show you, probably you will be using Kafka. It provides different connectors for different databases. So you have MySQL, Postgres, Mongo even, SQL Server. They are incubating ones, and probably already that's a lot of the market share here. And the traditional Debezium architecture looks like the following. You will have your Kafka, and inside of Kafka, you will have those Kafka Connect connectors. So one, for example, might be Debezium, which will be reading from MySQL. The other will be reading from Postgres. And every time there is something happening, then the logic inside will say, oh, write to this topic and write to this topic and write to this topic, and everything will be good. So I have a question. Does it matter if the DB cluster is read-only replication? Where are the logging implication on that, and what is the best practice for replication sync frequency? I'm not sure I understand the question. I will read it afterwards at the end, because I'm not sure I understand it. I will get back to it. So basically, Debezium is CDC. Debezium implements CDC. Every time there is a change, it will capture it, and it will write into a topic. So don't get me wrong, Kafka is super cool because it allows you to persist every one of those events into its topics. On the other side, it persists them, meaning it stores them on disk, meaning it's fast, but it could be much, much faster if it kept everything in memory. And it's not the case. So every time you persist something, every time you do stream processing with Kafka, then you put it into another topic. So you read from the disk and you put it on the disk again. It's much slower than if you keep everything in memory. So for that, we have Hazelcast Jet. And Hazelcast Jet is a pure stream processing engine, which is also distributed, but happens in memory. We are using Hazelcast IMDG. So if you want to use Hazelcast IMDG and Jet, you can just keep Hazelcast Jet. We have every feature inside of Jet that you have inside IMDG. And of course, it's open source. And of course, we still offer an enterprise offering that you could be interested in if you want support, if you want monitoring, if you want security. But by default, you have all the rest of what I will be showing here is clearly only open source. So you have the targets and you have the sources. Here, it can be Kafka itself, can be databases, it can be files, it can be application, it can be IMDG. And if there is nothing that suits you, so for example, you want to read from a web service, we have an API so you can build your own source. On the opposite side, we can also write to the same stuff, and again, an API, and you can write your own if there is nothing that suits you. And then between both, we have the Hazelcast Jet. And Hazelcast Jet is basically stream processing. So you can think about stream processing like Java 8 streams on steroids. So you can do everything you would do with Java 8 streams, but they are distributed not only on the node, so we can parallelize all the work on the different cores on a single machine, but they're also parallelized on the network. There are two deployment modes. The first deployment mode is embedded. If you're a Java developer, it's very, very cool because it means that you just like add Jet as a dependency to your Java application, and then you can just run it saying, hey, new Jet instance. And because it leverages IMDG, if you have three applications, they both do their new Jet instance, then they will broadcast to each other and they will form a cluster. So if you want to start Jet very fast, you generally do that. Now in production, you would probably change your way. What would you probably do is you would have a cluster of your own application, and then you would have a cluster of Jet nodes. And the advantage of that is twofold. First, you can scale your application and your Jet cluster in a different pace. For example, if you have issues with your application, and you can add more nodes, and you will be able to keep your simple number of nodes here. So you will like optimize your resources. And the other reason is here, you might have noticed, is the client API. So basically here, you don't need to use Java. You can use Java, but you can use Ruby, you can use Python, you can use C#, you can use C++, you can use Go, and you can use Node.js. So you could have like some of your application that are Java-based that write to the Jet cluster, and then you could be consuming with Node.js clients, for example. There are two concepts in Jet, and basically I believe while the semantics will be the same, the words might be a bit different, but basically there is something called a pipeline, and the pipeline is just code that is declarative. And then when you take that pipeline and you submit it to the stream processing engine, then it's a job, and then it's a running instance of your pipeline. And the processing engine handles, as I mentioned, everything. It handles the parallelization, it handles the code executions, it handles everything. So now that this is said, let's go back to our use case. Basically, we had this application, and there was a component that was writing to our database, and then our cache would be unsynced. If we had a Jet job here, we could read from the bin log. So we could be doing CDC, and every time there is an event, then Jet would be able to write to the cache. And then every time our application would need to read the cache, then the cache would be always fresh. That would be super good. So now, hope that the demo gods are with me. I will try to show it to you. So this is my main application. My main application is a Spring Boot application. I hope you have nothing against Spring Boots. As you can see here, I have, I'm using Jib, and Jib allows me to not have a Docker file, so I can create a Docker image out of my Java application without too many issues. I'm using Spring Boot Starter Web because I want to have a nice user interface. Timeleaf is the current way to do user interface, not GSPs anymore. And I will be using Spring Boot Starter Data JDBC and a simple, stupid H2 database in development, and MySQL when I'm deploying. And I will be using the integration with Hazelcast as well as Hazelcast itself. This application is very simple. I have a repository, and I have a controller. The controller uses the repository, and I can perhaps show it to you right now. Okay, so I have this application, and as you can see, it's very stupid. I have already some data because I have here this data.sql. So if you know about Spring, you know that this will be executed at start time. And here I have the schema. And I want to do the following. I want to update Johnny. Then it tells me Johnny and Jenny and Jenny. And if I refresh, I have everything. But here, when I read the log, nothing is read from the database. Everything is taken from the cache. And how it's done, I've created a person repository. So basically, when I do the select, I will first check. I have two caches. I have one for the entities and one for the queries. So I'm mimicking Hibernate. And basically, if it finds the query in the query cache, then it will get it directly from the cache. If it doesn't, then I will get it from the database and put, of course, everything into the cache. And when I save, I put the entities into the cache and it's done. Okay, so far so good. I will be doing some Docker Compose magic, and this is my Docker Compose. So I have this application, which is the one I showed you. Here, let's say that for the moment, I won't talk about it. I have the management center just if I need it to debug, and I have the database, which is MySQL. Let's do the Docker Compose stuff. I will bring everything down just to be sure, and I bring it up. So now it takes a bit of time because the database needs to start, and since it's the first start, MySQL takes a couple of seconds, I would say. Not a couple of minutes, but a couple of seconds. What I will be doing right now, I have several. I will Docker PS. I will stop the one called pipeline because that's where the magic happens. So first I want to show you how it doesn't work. So Docker Compose stop, and it's called pipeline. Okay, so let's get back to the application. So I still have the same data, and still everything is working as well. Johnny, Jenny, everything is fine. Now, I have another application that basically I want to emulate the fact that I am changing the database without going through the application. It's called update application. And if I run it, basically it connects to the application and it allows me to view the database states or to change it. So I can, here it's a command line application. I have lists here. So you can see I have Johnny and Jenny because my application updated it. And then I have, I can update something. So here I will update the first row with, let's say I will call it Bob. So here it will be Bob. And I will list the entities. So I have Bob. But of course, my cache is not aware of that. My cache still thinks that it's Johnny. Now, if I run the pipeline, here I will run the pipeline. So I will start pipeline. So what does the pipeline looks like? Here, the pipeline looks like the following. So notice that this is just configuration. This is not super interesting. I'm telling, hey, you should use this MySQL. This is the user, the password, blah, 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 blah. This is the real stuff. And as you can see, it's super short. I'm telling, hey, you will read from CDC. I don't need the timestamps. And every time you read an event, then you will convert it to a string. And then with that result, and as you can see, it's very similar to Java stream, you will apply this. So here it's a mapper. It's as if I had written map or to JSON. So here I'm just taking the string, okay, and I'm deserializing it to JSON. And then I will write it to the cache itself, and it's finished. So now, because the pipeline reads the latest changes, so Bob, I can refresh my application. And here I have Bob, and I did do nothing. And now we can try it again. And let's say that I want to, I must be here. I must be in the service. And I will update the second row with Daria, because here, and now I have the list, I have Daria, and if I refresh my application, I also have Daria. And now my cache is always in sync, always, always, always. Of course, it's not instant, but it's eventual consistency, and the window in which both the source of truth and the cache are not in sync is very, very small. So in this talk, I showed you about the caching trade-off. By implementing caches, you are basically accepting that your data must be a bit stale in order to improve reliability and performance. If you want to keep the cache, which is derived data, and the source of truth in sync, then I would really, really advise you to use event-based architectures. Because if you are doing regular batching at normal intervals, then you will probably either miss data, miss updates, or waste resources. And then finally, I introduced you to the change data capture and to Debezium, and how Hazelcast Jet integrates both to do the stuff in memory. So thanks for your attention. You can read my blog, where I publish weekly blog posts. You can follow me on Twitter. You can learn more about Jet and CDC in particular. And of course, if you're interested by doing that by yourself, I've created the repo on GitHub, so you can take the sources and try by yourself. And it's done. So now I might be reading the questions.